So today you are going to learn about the introduction to designing with composites. So basically composites is a evolving field where a lot of emphasis is on using new materials to outcome and to overcome the challenges that the industry is facing these days. So let's start the presentation. The agenda for today's webinar is a basic introduction to the composites material, metal versus composite material comparisons. Then we'll discuss about the constituents of composite material, that is matrix, or which we also call as resin, and then fiber and reinforcement. We'll also look at some core materials being used in the industry, which will enhance the performance of composites. We'll take a look at the various manufacturing methods used in the industry. And then the last topic on the agenda is quite interesting, where we'll see the application of composites in different fields. So the basic concept of composites is a combination of two or more dissimilar materials when combined together under controlled environment gives us a product which has unique properties and has enhanced properties compared to the constituents. So for example, as you see on your screen, we have a classic example of reinforced concrete. So what we have here is cement, reinforcement bars, sand or stone, and when they are combined in the right proportion, they give a very solid and robust concrete structure, which is actually better than any of the constituents. That's the philosophy of composite materials, to use different materials, and the outcome of that combination has much better properties than the constituents. Okay, so composites are basically two or more dissimilar materials which are combined together, and the outcome is better than the individual materials. So in a composite material, there are usually two or more constituents, which we define as matrix and reinforcement material. So the matrix material is actually the one which is holding the reinforcement materials together, and the reinforcing material, for example, in this case is the steel bars, which are the reinforcement or load carrying members. So they are the primary structure of the composites. So they are the ones who take the load, and their strength is very important. Whereas matrix is the one which binds these reinforcing materials together to give us high strength. So as you see, the fibers and matrix materials can either be metals, they can be ceramics, they can be polymers, or a combination of these. So in the industry these days, either it is aerospace or marine or architecture, most of the composite materials are made up of polymers, and polymer matrix composites are used widely in all the different industries these days. So the characteristics of composites are two or more physically well-defined and mechanically separable materials. So these materials are physically well-defined. They can be identified as different in to look at, and also with different mechanical properties, and they are separable materials. So you can look at them and identify that this material, the constituent A, is different from constituent B. So how are they produced? The composite materials are produced by mixing these two different materials in a controlled manner and have a uniform dispersion in order to achieve a part which has better qualities in terms of mechanical properties, in terms of finish, compared to the constituents that are used. The idea is to have a part which has better mechanical properties than the constituents. So what is the reason that we are now looking into composite materials? Why not we just work with the conventional materials that we have? Like we have steel, aluminum, titanium. Why don't we just use them? Why do we have the requirement to have some materials or advanced materials, in this case composite materials? The main thing is the whole industry is driven on a philosophy of weight saving. The reason for that is, for example, an aircraft which has to fly for thousands of hours needs fuel. The lighter the aircraft, the less fuel it uses, and then less fuel results in good business proposition. In order to gain profit, the airlines have to have aircrafts which are lighter and which can fly long distances, and that is where weight saving comes into picture. Now composites have an advantage over the conventional materials, which is lightweight structures. So having a lightweight structure always helps, not just in saving fuel in case of aircrafts or in case of any other automotive, but it also helps in various other ways. For example, the composite materials that we are talking about have a very high strength to weight ratio. So with a reduction in weight, you get a very strong and high strength material which replaces the conventional material. You have very high specific strength of composites, which is nothing but the strength of the material against its density, and also composite materials are very stiff. The other thing is these composite parts are tailor-made. What I mean by that is, when the parts are built or designed, they are designed in such a way that, considering the amount of strength required in each direction and the load cases, the parts are designed and the material is added in particular directions to overcome the loads that are being applied to it. So we don't need directional properties in all directions or strength in all directions. What we need is specific strength in specific directions to overcome the operational loads. Besides this, these days there is a requirement for beautiful and good looking structures and complicated, complex structures. So with the conventional metals, it is very difficult to produce single curvature, double curvature parts which are beautiful and good looking and which are huge in size. So in this case, composites play a very important role, as they can be formed into different complicated shapes and they are lightweight structures. This is very important in the architectural industry, where big roofs and architectural designs are being built using composite material rather than the usual metals which cannot be formed in those complex shapes. The other advantage of composite material is high resistance to corrosion. So metals have a disadvantage of corrosion, whereas composite materials have an advantage over the metals in terms of corrosion. They have high resistance to corrosion. Also, they have excellent fatigue resistance. So when cyclic loads are applied on them, they behave very well. They have dimensional stability. So what this means is the parts that are produced with aluminum or steel have a very high coefficient of thermal expansion compared to the parts produced from carbon fiber or glass fiber. So the parts have good dimensional stability, and with rise in temperature or reduction in temperature, the dimension of the part is quite stable. It doesn't vary a lot when compared to aluminum or steel. And this is one of the most important point where composites have an advantage on the conventional metal assemblies, is when you have a big part like for an aircraft where you're connecting a lot of parts, you need metal parts to be bolted to each other, riveted to each other. A lot of fixing and accessories are required. Whereas in composites, they are either bonded or they are laminated together, which is called co-curing. So you can eliminate the use of doubler plates, you can eliminate the use of fixations, you can eliminate the use of fasteners and rivets. I hope it is clear. If you have any questions, please make a note of it. We will answer the questions at the end of the session. Now, just like advantages, there are always some disadvantages. So composite materials also have some disadvantages. The first one being they are relatively high in cost, and the reason is they are special materials. So special materials are costly, and the other thing is they are susceptible to impact damages. What it means is, for example, there is a composite panel in the shop floor and somebody by accident drops a hammer on it. So the hammer, when it drops on the composite panel, it produces an impact damage. It might be very small, it might be big, it might be visible, it might not be visible, but the composite panels, when impacted, tend to have a damage on that. The other one is moisture pickup. So this is particularly a problem when there are parts which use core inserts to increase the section thickness and rigidity. Whenever we have cores, these cores tend to absorb moisture, and with the temperature variation, that is rise in temperature or fall in temperature, the core tends to behave in a different manner and reduces the strength and rigidity of the composite panel. So moisture pickup is a disadvantage, and in the industry there are different methods people have come up with to avoid this kind of moisture pickup. So when we discuss the core materials, we will take a look at this. And the next phenomena is lightning strike. When there is a thunderstorm, we have seen a lot of times there's a lightning strike, and what happens is a huge amount of energy is impacted on a particular, say in this case, a composite panel. And since the panel is non-conductive and it is not able to dissipate the energy, the lightning strike energy is converted into heat and it burns off the top of the composite panel. So in order to avoid the lightning strike damage, there are different methods being used in the industry, like use of copper foils and various methods of dissipation, so that every time there's a lightning strike on a composite part, the damage due to the energy is prevented and the energy is dissipated, either it is ground or it is dissipated back in the atmosphere. So it is a disadvantage, but there are ways around to work with it. The other important aspect is the tooling. Because composite materials require tooling, there is an additional cost associated with the production of these parts. So based on the type of resin, the type of fiber, the type of curing required, the tools are designed to suit. These also require special shop facilities. What this means is, when metal parts can be produced in the normal industry with the normal environment, on the other hand, composites need special facilities. So we need to control the temperature, humidity, and pressure in the factories where the composite parts are being manufactured. So there is some cost associated with establishment of facilities. Since composites are new materials and they are being designed and invented every day, there are new inspection techniques required to make sure that the composite parts which are produced are free of defects. So this is one area where the cost of the component goes up, because you're employing non-conventional inspection techniques like ultrasound, X-ray, etc. And then the most important thing is the manpower. To build composite material, we need skilled manpower, which is quite short these days. So this is one of the disadvantages. Now let's look at some challenges that we have to always keep in mind when we start to design parts with composites. Always remember that these materials are brittle. So when we are designing composite materials, we have to have this always in our mind, that these materials are brittle and they have to be designed considering the brittleness of this parts. The other thing is they are poor in impact performance. As I said, whenever the composite materials are impacted with some solid and robust parts, they tend to have visible or non-visible defects inside. So this is one of the challenges that we have to overcome. The next one is process sensitivity. So as I explained, composites are combination of two or more dissimilar materials, and they are put together in a controlled environment. So if the environmental parameters like temperature, humidity, pressure, if these things are being monitored, then the possibility of defects is very low. But if these process parameters are not controlled, there is a possibility of defects, and this is why we say they are process sensitive. The process has to be followed, and if the process is followed, the defects will be very minimal. But if the temperature is not controlled, if there is lots of humidity, then it affects the part which is being produced. So controlling the process parameters like temperature, humidity, pressure, etc. is very important. Then also composites have some environmental effects. So in the presence of moisture and temperature, there are certain defects that are induced while manufacturing. So those have to be considered. Then, as I said, one of the important parameter is cost and skill. So every time we design a part, the most important aspect is to control the cost and the quality. So cost, quality, and skilled manpower are all connected to each other in a production environment. So cost and skilled labor are one of the challenges when producing parts with composites. And the other thing is the raw materials. So most of the composite materials are special materials and they are stored in special containers or refrigerators. So with time, the mechanical properties of this material degrades. So this is called deterioration whilst they are in storage. So this has to be considered. So imagine if we have bought a carbon fiber material, pre-preg material, which we are storing in a refrigerator, there's a certain amount of time before which it has to be used, or else it expires and the mechanical properties are degrading. We have to always consider that in mind. That's one of the challenge. The other one is the shelf life and out life. So shelf life is the time until which we can store the raw material in refrigerators before it starts to degrade. Whereas the out life is once it is out of the refrigerator on the shop floor, how much time do we have to use this material and laminate before it starts to lose its properties or degrades. So these two times are also required to be considered while designing and working with composite parts. The other thing is storage. So if these materials are special and they require different types of refrigerated units to store, how about transporting the material, raw materials? Imagine the raw materials produced in Europe and you want to produce the parts in a factory in India. How do you transport them? You need special storages, you need special provisions to not just store the parts, but also to transport them between factories, between the supply chains. So this is one of the challenges that you have to think about while designing with composite materials. Now, just as we speak about advantages and disadvantages, one important thing is to compare them with the metals, because metal parts have been in use for many, many years, and they have their own advantages compared to composites. So let's do a quick comparison of metals versus the composite material to see how composite is different from metal and what are the advantages or disadvantages compared to the metal parts. So basically metals are isotropic material. They have the same mechanical properties in all three directions, whereas composites are anisotropic. They have different mechanical properties in different directions. The other thing is metals are integral, whereas composites are laminated. What laminated means is they are being built up one ply at a time. So you laminate one ply over the other, and that's how the composite materials are built up. Now coming to the metals, they are tough, whereas composite materials are brittle, as I explained previously. And metal parts are machined down, whereas composite parts are built up. So usually if you need a metal part, you take a raw plate or you take a block and machine it out, whereas composites are actually built by adding one layer on top of the other. So the construction is quite different between metal and composites. Metals are homogeneous, so they have the same uniform dispersion, whereas composites are heterogeneous. They have different non-uniform dispersions. For metals, since they are being used since many years, we have a very good database, whereas on composites, we are still inventing new materials and new methods and process and manufacturing techniques are being employed. So there is still a lot of scope to improve, and there is inadequate database on the composite materials. As I said, metals are susceptible to corrosion, whereas composites are non-corrosive. So this is one of the advantages of composite materials. Metals have low stress concentration because of the way they are built, because of their isotropic behavior and homogeneous nature, whereas composites are having high stress concentration. Usually on the ends of the part or where the part bends, there is a high stress concentration. This is due to the way or the process in which the parts are built and laminated. On the metals, we need less number of tests, whereas on composites, since we are dealing with new materials and this is a process sensitive material, we have to make more tests, we have to do more analysis on that, to understand how the material behaves compared to the metals. The analysis in the metals is quite simplified because we have the database, we know the properties are isotropic and homogeneous, and there are a lot of case studies already done on the metal parts. Whereas in composites, these are tailor-made parts. So there is a complex analysis involved based on the design, and rigorous analysis is required to make sure the parts are safe to design and use. The other thing is the metal parts can be produced in conventional facilities, whereas composite materials need special facilities. As I discussed, they need to have good controlled temperature, humidity, and good facilities for production. Now let's look into the constituents of a composite part, which is matrix or resin, and fiber and reinforcement. So let's start with resin systems or matrix. So matrix is basically the bonding material which surrounds the fiber and gives strength to the part, and it transfers stresses between the fibers. The key to the strength of composite lies in the ability of the matrix to transfer loads to the reinforcing fiber. So basically what matrix material does is it holds the fibers together and supports the fibers to stay in the required position, and also it transfers the loads between the fibers. So matrix is the one that increases the toughness of the composite material, and it protects the fibers from damage. So basically it is the secondary member in a composite, and the function of this is to hold the fiber or the load carrying members together and transfer the load between them. There are various types of matrix materials used, but what I have listed here are the ones that are generally used in the industry. The most commonly used is polymer matrix, and polymer matrix also has a lot of other resins being used. I have mentioned 4 of them which are widely used. The first one is epoxy, then there is polyester, and then there is BMI, bisamalide, and then there is phenolic. So these are the polymer matrix which are commonly used. Similarly, there are metal matrix and ceramic matrix which are being used in the industry. Examples of metal matrix is, say, aluminum alloys which are being used in aircraft industry. Aluminum alloys like 6061, 7075, 5058. These are all examples of metal matrix. There are also metal matrix based on titanium material. Whereas coming to the ceramic matrix, these are again ceramic materials, and they provide high resistance to heat.